Today we're going to take a look at solving inequalities. So the first question I have for you is -4 a solution to the inequality below? So take a minute, pause the video, copy down the problem, and then try to figure out if -4 is a solution. Now that you've done all the work, let's see what you come up with. So you should have the following. 5 parentheses, -4 plus 7 minus 3, 1 minus 2 times -4 is greater than 10 minus 3 parentheses 3 minus -4 becomes plus 4 minus 1. If you go through and start simplifying that down, if you get a true statement, then it is a solution. And if you get a false statement, then it's not. Let's see, 1 minus 2 times -4 is 9. Make sure you're following order of operations as you're doing this. Alright, almost there. So on the left-hand side I have -12. And then on the right-hand side, I'm also going to have -12. So, is -12 greater than -12? And the answer is no. It is not. So -4 is not a solution to this inequality. But let me ask you a question. If I were to change the problem to have an equal to, if that line were there, then it would be yes, this is a solution. Okay? So this is the answer that you should have. But if there was an equal to in the inequality, this would be a true statement because -12 would be equal to -12. Then it would work. Alright, let's take a look at some basic solving graph. So instead of just checking a solution, you should be able to go through and solve for a variable. And you're going to solve this the exact same way you solve a regular equation. You're just going to pretend that inequality symbol is an equal sign. The only time you need to flip the symbol around is if you're going to multiply or divide both sides by a negative number. So we're going to go through and solve. Here we're going to have 3b minus 2b plus 10 is less than 2b plus 8. Combine like terms, b plus 10 is less than 2b plus 8. I'm going to subtract b from both sides, subtract 8 from both sides, and if you read it from the b, you should end up with b is greater than 2. And that's because the open side of the inequality is facing the b, so that's the bigger side. Now to graph that, you need to draw yourself a number line, just mark the value 2 on there, and then you have to decide is this an open circle or a closed circle. So looking at this one, because there's no equal to in this inequality symbol here, that means that we have an open circle above 2. You could also put it on 2 on the number line down here if you prefer, but I tend to do my graphs above. Okay, since b is greater than 2, greater than means go to the right. Okay, so it's all numbers bigger than 2 would satisfy this inequality. The one below, -2/5 p is greater than or equal to 10. You can do this in two different ways. You can clear the fractions by multiplying the entire equation by 5. And that would give you -2p is greater than or equal to 50. And then you can divide through by -2 and get p, switch the symbol around because you're dividing by a negative, and get -25. The alternative from the beginning is just to do times the reciprocal of fraction, -5 over 2. That would also get you to this same step. Okay? You would just flip the symbol around right away because it would be a one-step process. Alright, so graphing that, again, you only need to mark the numbers that are important for your solution, -25. This one's going to have an equal to in it, so I'm going to draw a circle and then color it in. And then since p is less than or equal to -25, that means go to the left. It needs smaller numbers. So it's all numbers smaller than or equal to -25. Okay. Let's take a look at some with bigger fractions involved. The best thing to do here is to just start by clearing fractions. So we're going to use that multiplied by the LCD technique. So we're going to take the entire equation, in this case, multiply it by 10, or 10 over 1. Okay. So that's going to give me 10 divided by 2 for the first fraction is 5. So 5 times x minus 4 plus 1 times 10 is 10, greater than 3x times 10 is 30x. 30x divided by 5 is 6x. And then solve this equation from there, or rather this inequality from there. So 5x minus 20 plus 10 is greater than 6x. I'm going to subtract 5x from both sides, combine like terms on the left. Negative 10 is greater than x. So x is smaller than negative 10. So now if we graph that on the number line, here's our number line. I'm just going to mark negative 10. You have to decide open circle or closed circle. And again, you're looking at this symbol right here to decide that. No equal to is an open circle. Equal to is a closed circle. So this is an open circle. X is the smaller thing because it's on the point side. So x is smaller than negative 10 goes to the left. Okay. Down here, you could say that the LCD on number 4 is 6, but you could also take a look at this right here. This reduces down to 1/2 to begin with. So then, the LCD is really 2. So we're going to go through and multiply everything by 2 here. So that's just going to get rid of all the denominators, and I'll be left with 3a plus 4 is less than 3a minus 1 plus 5. Okay, so if I subtract the 3a's, I'm going to get 4 is less than negative 1 plus 5 is 4. Well, is this a true statement? So what do you think? So if we go through and say, well, 4 is not bigger than 4, that doesn't make any sense, so this is going to have no solution. So if we go to graph that, well, how do we graph something that has no solution? If 4 can't be bigger than 4, so that means I would mark any number on the number line, and then you can leave it blank, or you can write the words no solution above it. I'm going to abbreviate, no solution. Okay. Now again, keep in mind, if we were to go back and change the problem and make this be an equal to inequality, well, that would be a true statement, and that would then change it to all real numbers would work. So then you could mark, again, any number, and to do all real numbers, you would draw an arrow showing that it's covering everything, no circles anywhere. So this would be if the solution was all real numbers. Okay, so there's an example where you could get no solution if there's no equal to. The equal to would make it all real numbers because anything would work. Okay, let's take a look at compound inequalities. So a compound inequality is when you have more than one inequality in the problem. All right, and there's a very important distinction between an and inequality and an or inequality. Something is a solution to an and inequality if every solution satisfies both inequalities. So I'm going to write that all solutions will satisfy both inequalities. Oops, that's an A. Will satisfy both. Whoopsies. Don't know what happened there. Okay. Inequalities. Sorry, this is a little messy. Okay. So if you had something like x is greater than negative 5 and x is less than 2, the number 0 would work. Because x equals 0 is both bigger than negative 5 and smaller than 2. A number like x equals 4 does not. And that's because, well, 4 is bigger than -5, 4 is not also smaller than 2. Okay? And or inequality is actually a little bit easier in the sense that it doesn't have to satisfy both. A solution must satisfy at least one of the inequalities. So a solution must satisfy at least one of the inequalities. It does not have to satisfy both. Okay? Major difference. So if we went with the same example, actually no, we're going to go with a different example. If I said x is greater than 4 or x is less than 1, the number, say, x equals 5 works because it satisfies the first inequality. 5 is bigger than 4. While 5 is not smaller than 1, it doesn't have to. It just has to work in one of them. Okay? So let's take a look at how these graphs will look. So it says to graph each inequality and describe the solution. So I'm going to describe out loud. I'm not going to write them down, but I am going to create the graph. So again, we just need to mark the numbers that are important. So that's 2 and -3. Make sure you put the smaller number on the left and the bigger number on the right. All right. Now let's think about this. So I'm going to do a little drawing, erase, and then write the final answer. So we've got x is smaller than 2. X is smaller than 2 looks like this. And it says, and x is bigger than or equal to -3. So here's bigger than or equal to -3. And now I need to figure out, well, where are the numbers that work for both inequalities? So here you're looking for where do they overlap? And that's this section in between -3 and 2. So the final graph, now I'm going to erase this, the final graph will look like this. We are going to have a filled-in circle at -3, an open circle at 2, and they're going to get connected together, showing it's all the numbers in between -3 and 2. An open circle at 2, and a filled-in circle, a closed circle at -3. So now when we look at the next one, the only difference is the fact that it says or. So we start with -3 and a 2. And now we're going to go through the same process. Now keep in mind, the lines look like this. Open circle going to the left, closed circle going to the right, and any number that's covered by any part of the line is a part of our solution. So all the numbers over here, less than -3 work, all the numbers in the middle work, and all the numbers bigger than 2 work. So this is an example where it's all real numbers. So our graph is going to look like our all real numbers graph. This one is all real numbers. Okay. 2 more graph, and then we're going to do 3 solve. Getting there, guys. Okay, so now we've got x is bigger than or equal to -1, and it's bigger than 2. So if I graph the first one, bigger than or equal to -1, that would be a filled-in circle going to the right, and x is bigger than 2, open circle going to the right. Now where are they overlapping? Well, there's nothing before -1. Between -1 and 2, only one of them works. So we're going to actually end up just keeping the x is greater than 2. That's where the overlap is. So I'm going to go back and erase this portion because that was not where the overlap was. And because it says and, we're looking for overlap. So this is our final answer here. So it's all numbers bigger than 2 will satisfy this one. Now if we have the same situation but we switch it to an or, what will that answer look like? So we're starting with this, bigger than 2, closed circle, bigger than or equal to -1. This is the anything goes graph. So as many numbers as I can cover, that's what it's going to keep. I'm going to get rid of the open circle at 2 and that arrow. So this is what our final graph will actually look like here. Whoop. I'll fix that. So we've got our line, 2, and our arrow. Okay. So you have to be very careful. Again, when you're looking at an and, you're looking for overlap. And when you're looking at an or, you're looking to cover as many numbers as you possibly can with the arrows that you have. All right, let's go through 3 solving problems and then we'll be done. This first one is an and inequality. You could write it like this. This would be -7 is less than 2x plus 3. And. So this is an and. Oops. And then it would be 2x plus 3 is less than or equal to 11. Okay? But it's easier to solve it from where we are in the middle. Okay? Whatever you do in the middle portion, you're going to do on both sides. So I'm going to take away 3, take away 3, take away 3. And get -10 is less than 2x, which is less than or equal to 8. Then I'm going to divide by 2, divide by 2, divide by 2. So what do you do in the middle? You do on both sides. I'm going to get -5 is less than x, which is less than or equal to 4. Alright, so it's basically all the numbers between -5 and 4. So I'm going to go to our number line. Here's -5. Oops. -5. +4. We have an open circle at -5, and we need to go bigger than that. We have a closed circle at 4. We need to go smaller than that. So they're going to connect because one would be going this way, one would be going that way. The overlap is in the middle. Okay? Alright. This one down here is separated out into 2 separate inequalities, so it might be a little bit easier to solve. I'm going to go through and get rid of the 1 and make this -4x is bigger than 6. So this one's going to give us a fraction. Keep in mind you're dividing by negative, so the symbol flips around. -6 divided by 4 is 3 divided by 2. Okay, so x is going to be smaller than -3/2. This other one, I'm going to get the distributive property to get 3x minus 3 is less than 5x. -3 is less than 2x. And I'm going to get x is bigger than, dividing by a positive, so don't flip it around, -3/2. So if I look at that graph, remember, this is an or, so anything that works, works. We got the same number twice, but the inequalities are a little bit different. So one of them, the first one, x is smaller than -3/2. The second one, x is bigger than -3/2. So it's an or, meaning anything that I can cover will work. So this one, everything smaller than -3/2 works, everything bigger than -3/2 works. So it looks like everything's going to work except for -3/2. So I'm going to go back and I'm going to erase this portion up here. Whoops. Erase, erase, erase. There we go. And we're going to draw it so it looks like all real numbers, but there's a hole at -3/2. So again, this is all real numbers except for -3/2. Now, I said that there were going to be 3 problems that we were going to solve, but this is actually our last one. We're going to talk about how number 10 could change if this was an and. Okay? Now, if we switch number 10 to an and, make its own little graph for that. Okay? So we have -3/2 here. We had 1 going to the left, 1 going to the right. The only spot that they overlapped was at the circles. Now the circles are not filled in, so that means that there's actually no solution if I change this to an and. So I would erase those pieces and say that it's no solution. But you could write like this, or you could write above it, no solution. Okay? If they were closed circles instead of open circles, they would have overlapped at the single point at -3/2, so your answer would actually just be a closed circle above -3/2, again, if it was an and. and both symbols had an equal to. Okay? All right, I know that was a lot. I apologize for the length of the video, but your homework is to go through and work on the inequalities worksheet. So there are some bookwork problems on 2 different pages to take care of, and then there are 10 inequalities to graph right there on your worksheet. We'll go over all of this at the beginning of class next time I see you. All right, I hope you found this helpful.